All right, and welcome back. So today we are going to be talking about how to transform these linear functions and how to compare and analyze the difference or the transformation of multiple linear functions that are going to be on the same graph, or if we're given a system. So please have out your guide and notes. Let's begin. So the function f of x is equal to x is called the parent function for the family of linear functions. You may also hear the phrase mother function. Essentially, it's just the OG. It's the original. It's what we're always going to be comparing to if we have a set or a family. Again, it's just going to be what we always start with is going to be a quote unquote diagonal line going through all of the same x and y values. So 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, negative 2 comma negative 2. That's going to be our quote unquote parent function or the mother function for a family, which is just multiple linear functions. So changing the y-intercept will shift this line up or down. This is called a translation. So direct variation, when we first talked about this, it was always going through the origin. And then we have slope-intercept form, right, which is just direct variation going through a different y-intercept. That's a translation. It's just shifting it up or down. Instead of going through the origin, we're now going through, let's say, 3, right? Or we're going through negative 4 on the y-axis. That's called a translation. So if we were to graph f of x is equal to x, g of x is equal to x plus 2, and h of x is equal to x minus 4, we want to describe the transformations. So f of x is equal to x is the parent function. It's also called the mother function. If we graph these, we're going to see exactly what happened. Well, our mother function is currently going through our origin. Let me highlight that for you. Right, so f of x is equal to x is currently graphed in yellow. We're going to have g of x is equal to x plus 2 is graphed in green. And then we're going to have h of x equal to x minus 4 is going to be in blue, right? And we have to describe, hey, like what is happening here? Well, if we start with our parent function, the yellow line, go up to our green, well, they're parallel, they have the same slope, but it's just shifted 2 units up. So it would be a translation of 2 units up. If we're going back to our mother function and the yellow, and we go down to our blue line, well, that was just a translation 4 units down. I just shifted 4 units down. If we wanted to compare our green to our blue, we could definitely do that. Well, our green starts way up top, our blue is down at the bottom. So going from green down to blue, we shifted 6 units down. Going from blue up to green, we shifted 6 units up, right? So we translated 6 units up or translated 6 units down. And again, because the y-intercept of g of x is 2, so the graph shifts up 2 units from f of x, and likewise the y-intercept of h of x is negative 4, so the graph shifts down 4 units from f of x. So with this, let's talk about rotations. So changing the slope of a line will change the steepness of that line. This is called a rotation, right? Like we're turning on our coordinate plane. So we're going to graph f of x is equal to x, g of x is equal to 4x, and h of x is equal to 1/2 x. And we're going to describe those transformations. So over on the right-hand side here, we have these 3 functions that are being graphed. Let's again go with f of x is equal to x. Let's graph that in yellow. We have g of x is equal to 4x. Let's graph that in green. And likewise, let's graph h of x is equal to 1/2 x in blue. So we're going to see that there's a couple of things happening over here. We are going to see that g of x, that green line, is steeper, right? So we are turning it from the left. If we're comparing to our OG, our parent function, f of x is equal to x, and we turn it to be the blue, well, we rotated it to the right. So we have these directions. If we're going from yellow to green, we are turning counter clockwise. So from yellow to green, we're going counterclockwise. So let's jot that down. We're going counterclockwise because we're going in the opposite direction of our clock. So this is going to be counterclockwise. Likewise, if we are turning in the right direction, if we're going from yellow to blue, well, we are turning clockwise. We're going in the direction of a clock. We call that clockwise. So as we compare our slopes, we compare these lines as being steeper or less steep, we're going to be able to apply a direction. So if we're turning to the left, we're going counterclockwise. If we're turning to the right, we're going clockwise. Awesome. With that in mind, please work on problems 1 through 4 on the guided notes. Turn them over and let's resume when you're ready to go. Okay, so we talked about 2 transformations so far. We talked about translation, which is just like shifting. We talked about rotation, which is just turning. Now we're going to talk about reflection. So when the line or the slope of a line is multiplied by -1, the graph is reflected across the y-axis. This is called a reflection. So if we are going to be graphing g of x is equal to 4x, and then we're asked to reflect the graph across the y-axis, we're going to write that new function. Well, all we have to do is change our slope by a factor of -1. So again, if we have g of x is equal to 4x, let's highlight that. G of x is equal to 4x. We are starting there. I totally missed that. Let me shift that for you. Let me translate that to the left. Haha, see what I did there? Nice. Let me now rotate it to get it onto that line. Nice. So g of x is equal to 4x is going to be graphed in green, and we want to change our slope by a factor of -1. So instead of it being 4x, or the slope value being 4, it's going to be -4. So we are reflecting across that y-axis. So if I highlight now h of x being in blue, it's going to form a reflection. It's going to be performing a reflection. One thing that you're going to notice is that the distance away from that y-axis is going to be equal. It's going to be equal. So for example, if I were to find the distance from the y-axis of this point right there, how many units away is it? Well, it's 1 unit. And now if I reflect it over that y-axis, I have its mirror image, right? When you look in a mirror, you get your reflection. Well, we should expect that this is also 1 unit away. And that's going to occur every single time. When we have a line of reflection, we're going to have the same distance away from that line of reflection. So the new function, again, h of x is equal to -4x, because they are going to be opposites. Let's go over to the right-hand side now. Let me select my selection. Whoa, that was crazy. So more than one transformation can be applied to a linear function. We're going to graph f of x is equal to x, and we're going to graph g of x is equal to 2x minus 3, and we're going to describe the transformation of f of x to g of x. So when we graph it, again, let's highlight f of x is equal to x. That's our original. G of x is equal to 2x minus 3. Put that in green. A couple of things happened here, right? We didn't just translate, and we didn't just become less steep or more steep. We have a couple of things happening. This new line is going to be steeper, and we also shifted down 3 units. We can compare steepness of our slopes because we can look at the values of our slope. Well, f of x is equal to x, slope has a value of 1. G of x is equal to 2x minus 3, that slope has a value of 2. So 2 is greater than 1, meaning it's going to be more steep, or it's going to be going more vertical. Our slope has a bigger value. And now our y-intercept has changed. It's no longer at 0, it's going to be at -3. So the graph is going to be steeper, and it also shifted down 3 units. So when we write our conclusion, the slope of g of x is 2, so the line is steeper, which has a slope of 1. The y-intercept, again, is -3, so it's translated down 3 units after it's been rotated. So to get from the yellow towards the green, we have to shift it counterclockwise to the left. And then we go, we drop down 3 units on that y-axis. And that happens again after we have rotated. Awesome. With this in mind, please work on problems 5 through 11 on the guided notes. Keep making yourself proud. Great job with this. Please let me know if you have any questions. I'll talk to you soon.